Hi and welcome. My name is Rafael Taubinger and I am Technical Marketing Specialist. And this is a joint session from IAR Systems and QA Systems. I have with me Adam Mackay, that is Integrations Manager at QA Systems.
Hi, Rafael. Hi, everyone. Pleased to join you for this session. It's going to be a great overview of the product offerings from both our companies.
Good. We are going to discuss how to make use of impact analysis and regression testing for robust C applications. Before I get started, you will have probably noticed that you're all in mute, so please make use of the QA panel available in GoToWebinar to send us all your questions or let us know if you have any issues. We have a team available to assist you on the fly. This session will be recorded and you will get a follow-up email in up to 48 hours. And the slides are also available in the handout menu for download. So let's move on. As I already mentioned, my name is Rafael and I work for IAR Systems. You might already be familiar with IAR Systems, but if I can say a few words, IAR Systems is the world leading provider of software for programming of microcontrollers and processors in embedded systems. Our headquarters are located in Uppsala, Sweden, and we have sales and support offices, in fact, 14 all over the world. The IAR Embedded Workbench is by many considered the best compiler and debugger toolchain in the industry. We also provide build tools for automated workflows, static and runtime analysis tools, security tools, and certified tools for 8, 16, 32, and 64-bit MCUs and PUs. Our development tools are used by many of the world's largest corporations, as well as thousands of small and medium-sized companies in a range of industries such as automotive, industrial automation, medical, consumer electronics, and IoT. So, Adam, can you also give us a brief introduction about yourself and QA Systems?
Yes, of course. So my name's Adam from QA Systems. I'm based in the UK office, and my role as Integration Manager allows me to interact with our customers and also our development team to help support our customers produce, maintain, and test their quality software and also their process improvement. I'm passionate about development, and I've been lucky enough to collaborate on a number of software projects with some highly regarded developers and their teams. So QA Systems, we were formed back in 1996, and our focus has always been improving the quality of our customers' software, particularly in the safety critical space. So we work with developers of C and C++ systems and produce a range of tools to allow them to perform unit and integration tests against their code, monitor the coverage that they're getting while running the tests, and also support the checking of the code they're writing through static analysis solutions. So we have a global footprint with the main technical development center in the UK, satellite development center over in Vietnam. Our commercial headquarters is based just outside of Stuttgart in Germany, and we have supporting offices spread from the US right through Europe, and also a global reseller network. So wherever you're located, there'll be a QA Systems representative able to assist. On successful projects, the processes, the strategy are always very simple, and we'd like to walk you through some of the latest work that we've been doing in this webinar.
Wonderful. So the agenda today will start by exploring impact analysis. We will move to automated workflows, get some extra background about Cantata with impact analysis together with IAR Systems toolchain. And we will actually spend most of the time in the practical demo. And to finalize, we have a brief summary. And we will also, of course, spend enough time to go over the Q&A. So why impact analysis? Let me get started here. So when we interact with customers, Of course, CI, or better continuous integration, is always mentioned. I mean, companies use it in different ways, simplified or with different orchestrators like Jenkins, GitHub, GitLab, or even containerized if they want to scale it, I mean, with Docker. This is for all industries, but if compliance with standards comes on top with additional testing and reporting, it mainly becomes mandatory. So in short, functional safety adds the requisite of regression testing. In a sense, it is all about automating the build and testing of code every time a team member commits changes to the version control. This all sounds beautiful in theory. However, what we learn is that this all can become a nightmare and require a lot of processing power and time to be executed.
I think we're seeing the same things from our side, Rafael. So particularly in recent years, the focus has been on kind of introducing DevOps technology and continuous integration, and trying to take the techniques that have been developed in the kind of more enterprise software world and apply them to the safety critical space. So these are kind of hot topics currently for people developing safety critical code, how to bring the best practice from the wider software world into these more specialist projects. So what kind of strategies have you kind of found your customers moving towards to put that in place?
So from our side, there are some strategies that can be used, and we have seen customers doing the CI or automated builds on Linux to get extra performance. I mean, build faster. This can actually reduce, in a generic way, 30 to even up to 50% of the total build and testing time.
I think we've seen similar results, maybe even higher than that, when you can bring in parallelization and split the build and the test runs across multiple machines. So there's definitely a lot of power available in these techniques. So there's lots of feedback that we're getting from customers that actually reducing the amount of time that it takes to run these regression tests is kind of key to the success of their project. Just to give you one example, a customer that we were working with started building up a regression test suite that initially, when they ran it end to end, took a few hours, and by the time they were reaching the end of the project, that full regression test run was taking in excess of a day. So obviously it's not practical to run that on a regular basis. By bringing in this kind of analysis, parallelization, and DevOps technologies, we can actually help customers reduce the regression test run from as much as this 24-hour example right down to a matter of 20 minutes in some cases. So maybe if I just outline what we mean by impact analysis a little bit more. What we're finding is customers like to run their test suite as frequently as possible, and the gold standard is to run a suite of tests immediately upon code check-in. The challenge that we're seeing is identifying which code changes necessitate which tests need to be rerun. And using traditional techniques, that linkage isn't always clear. So in our testing tools with Cantata, we've baked in an impact analysis routine, which links every test resource, every header file, every source file with the test that you're rerunning. So if there's been a change to one of these resources, we can immediately ascertain a list of tests that need to be rerun to validate that change. And it's by doing that kind of analysis, the impact analysis, figuring out what bits of code affect which tests, that really allow you to speed up these regression test runs and allow you to get the most out of the results you're achieving. So today, most companies continue to demand faster releases and innovative software to stand up to the dynamic market scenario and steep competition that we're all seeing. And with companies leaning on DevOps and the agile philosophy of software development, efficient testing constitutes a critical part of it. The once popular manual testing approach doesn't really do the trick anymore for modern connected devices and intricate embedded applications. And I know I'm not alone in stating this. I know, Rafael, you've seen similar things in your work at IAR. So a well-designed process can help cut costs and timescales, and it can also ensure end product quality. So let's share our experiences of implementing this and the technology that we have to support and back that up. Okay, so this is a graph that I think sets the scene really well, explaining what we're trying to achieve. So it's kind of folklore in the software development world about the costs of fixing defects. And a lot of that comes from an early study done by the Systems Institute at IBM. And they did a study, and it was reported to them that the cost to fix a defect in the code increases exponentially as you come towards the end of a project. So obviously with the traditional V model, you do all of your design and requirements work up front, and then you drop into the coding stage where a lot of the software is put together before formally then moving on to the unit test, functional test, system test stages. And if you're lucky, if you pick up a coding defect at the unit test, maybe the cost to fix that isn't too great. It's not been long since the code was written, so the developers are quite efficient at going back and fixing and recompiling. If you're unlucky and you happen to find a bug once it's been released to your customer base and you're in maintenance mode, obviously applying a fix to that code base and rolling that back out can cost considerably more. And I think the figure quoted by IBM was up to 100 times more to fix a defect that's found in the maintenance stage compared to early on in the coding stage. This defect line here shows where obviously most coding defects get placed into the system you're developing, and we're obviously seeing a big peak at the point where you're on the developer desktop cutting code. There will be some defects that get introduced as the system builds up. So as you assemble different units of code, maybe there's some interactions that don't work quite as intended. So there is a little defect peak towards the end as things come together. But the majority of them are introduced at the coding stage. And then applying the way you catch the bugs. Let's say, for argument's sake, that you're catching bugs throughout the project development lifecycle. What you really want to do is to try and apply technology and technique to shift that defect detection point more to the left, so earlier on in the development cycle of your project. And by doing that, you're finding the defects at the point that they're cheapest to fix and also quickest to fix. There's a good example from the recent Samsung phone fiasco. I think it was in the news a few years ago. It was with the Note 7, where they had a software problem with their battery charging. It basically meant that they had to recall all of that model of phone because the software fault was causing some batteries to overcharge, and there was a fire risk there. So that lack of detecting the defect early on seriously affected Samsung in quite a dramatic way. Had they maybe introduced some of the techniques we're going to talk about, that problem could have been found earlier on and saved a lot of people a lot of headaches. So this is a nice cartoon that kind of illustrates the point. There's a traditional way of developing software. You kind of cut the code and then you move on to the testing phase. And you kind of, if you find a problem, you go back, you apply a patch, find another problem, go back and apply a patch. And at some point, all of these patches and fixes kind of roll together and increase what we call technical debt. So that is code that kind of turns from a nicely designed, nicely envisaged system that you had at the outset into something that more resembles a plate of spaghetti. The code base becomes unwieldy, difficult to maintain with all of these subsequent patches. So the way to address that really is to adopt some kind of iterative approach where you're bouncing backwards and forwards as frequently as possible between the code creation stage and the test stage. That not only reduces the cost of fixing defects that you may uncover, but it also has the nice side effect of keeping your code nicely maintainable and in check. So I think, Rafael, you were going to talk a little bit about how IAR systems support that kind of methodology with automated workflows.
Yes, definitely. Today's development practices require automated processes to ensure quality and to run builds and tests continuously. Continuous integration pipelines are being used more and more. Here is an outline which shows a typical DevOps scenario when using the IAR embedded workbench and also the IAR build tools with Jenkins as orchestrator and Git for version control. This is actually what many of our customers, or better, our mutual customers, are doing nowadays. If we have a closer look on the left side, we have the IAR embedded workbench. That's, of course, the best solution for desk development, and each developer should, of course, also have a debug probe at that side. But then, if we look on the right side, we have the IAR build tools running even in Docker containers. So it's optimized for automated workflows. So without complicating it further here, all the changes in the source code, even minor ones, will trigger builds and tests so that the changes can be validated before merging them into the main branch. IAR embedded workbench and the IAR build tools enable a smooth transition and integration from the day-to-day development into the CI pipelines. We also have some additional information if you are interested about the IAR build tools and Jenkins on our GitHub site that it's displayed on the link below. Additionally, maybe some of you might not be aware yet, but if I explain a bit more about the IAR build tools, especially talking about the IAR build tools for ARM from version 9.20 and beyond. So it allows you to build embedded software projects with cross-platform host support. So it comes with all the tools required for building entire applications. I mean, the compiler, the linker, the assembler, libraries, and so on. You can also have static analysis that's also available.
So does that mean, Rafael, that you'd be able to maybe have your developer workstation on Windows, so your developers are building up, coding their application in the Windows environment, but then when it comes to supporting CI infrastructure, maybe it's more normal for that to be Linux hosted. The code will simply recompile on Linux in the CI pipeline in the same way it does on their Windows-based desktop.
Yes, that's correct. So if you have a project which was created with IAR embedded workbench, then the IAR command line build utility that we also call IAR build can build the same project using the same recipe. And this can be done on Linux. We currently support Ubuntu or Red Hat. So that's straightforward to be used. Yeah. Command line tools, they are very flexible, and you could also, of course, write your own recipe using other build systems such as Make or even Ninja. Very important also to mention, and I will talk a bit more about that, the IAR build tools for ARM are also available as a pre-certified edition.
That's great. And it's interesting that you mentioned Make there. So the underlying build system that gets generated automatically when using our Cantata testing tool is entirely Make based. And I've had some good success in recompiling the tests that are coming out of Cantata using our standard Makefile build system, but in in conjunction with the IAR build tools. So there's a lot of value that can be extracted from that kind of approach.
Definitely, and the customers will of course benefit about the functionality working in an easy way. Yeah.
Mm-hmm.
Good. So finally, maybe a few words about the pre-certified tools. High integrity standards for industrial, automotive, medical, railway, agriculture, and machinery require companies to provide extensive justification for selecting a development tool, unless this tool is already pre-certified. So the IAR embedded workbench and IAR build tools are actually available as pre-certified version, and it's certified by TÜV SÜD with a long-term support. And we also have a special functional safety agreement. It actually covers 10 safety standards, as you can see in the screen. And of course, we provide full flexibility with a wide selection of tools across architectures. I mean, aside of ARM, we also support RISC-V, STM8, Renesas, and so on. So maybe also important to mention here is that the safety certificate gets actually renewed as long as the customers have an agreement active. So this is opposed to maybe other solutions where this is limited to 5 years.
That's great. And I don't have a similar slide in my deck, unfortunately, at the moment for the Cantata tools, but while you've got that on the screen, just to mention that we use the same certification body for our Cantata testing tool, so TÜV SÜD, and our products are all pre-certified. And again, as long as you have a valid maintenance agreement, subsequent versions of the tool will be supplied to you along with this full pre-certification. So I think it's quite important to have the independent certification from these bodies, particularly in the safety critical world that we're addressing.
Definitely, and once again, it shows that both tools work great together. Yeah.
That's right. That's right.
So Adam, now back to you. Can you tell us a bit more about Cantata with impact analysis and so on?
Yes, of course. I'll start with a few nice graphics. So regression testing, I think everyone's familiar with. That's the process of rerunning tests that have previously passed to ensure that a recent code change hasn't broken existing functionality. So this is done to ensure that the software continues to work as it did before, and that the new features haven't altered existing functionality in a way that was not intended. The primary goal of regression testing is to find bugs which were introduced into the application when new code was added or existing code was changed. Regression testing ensures that these bugs are corrected before they're deployed into production. So not only is regression testing widely adopted as best practice, more recently we've seen the growth of continuous integration and continuous deployment kind of DevOps approaches. So the change-based testing approach makes it efficient for very large sets of existing tests to be selectively rerun, depending on the scope of the software change impacting that subset of tests. So this is where you get your time saving by building up a big suite of regression tests and then selectively rerunning those dependent on the code change impact that you've recently made. A regression test can be run more efficiently in that way. And when coupled with parallelization techniques and running the tests across multiple build systems, we can really increase the speed of that regression test run much more. So modern build management tools such as Jenkins or Bamboo can be used with our testing tools and the IAR build tools to help with this build parallelization. And with the impact analysis part of Cantata, we can pick out and selectively rerun only the necessary tests that are required. So we like to call ourselves a test-centric approach. We put the testing effort at the center of our CI/CD workflow, and the aim is always to write unit tests alongside the code as you're developing the code, because obviously the knowledge and the experience of how the code work is in the developer's head at that point, and any defects can be quickly addressed. So after we've selected and designed suitable test cases, we can execute them. Running the tests can be manual, semi-automatic, or fully automatic. The level of automation depends on two factors really, the liability for software errors and the repetition rate of the tests. So well-designed test scripts allow an exact repeatability of tests, and well-designed pipelines execute only the required tests at the required time. So parallelization during the build and execution stages can really help to speed things up, allowing you to obtain reports more quickly. In DevOps environments, the gold standard is to execute a complete set of automated tests on each code modification. And this really allows for rapid feedback to developers and gives them the confidence that the code is always in a tested and ready to release state. Outside of DevOps, test automation allows for easy regression testing, and this basically allows developers to ensure that the added functionality doesn't compromise any previous testing effort. I'd like to mention that in my experience, some developers in the safety critical world are reluctant to switch to automated processes. There's this stigma of fear and uncertainty that introduces. However, there are considerable benefits that can be achieved by adopting that methodology, and with suitable tooling, things really aren't that tricky. It's an indispensable technique in the safety critical space. So just let me show you a little bit more about what I mean by impact analysis. This sets a tag against every software resource that's pulled into a test build, and by tracking the state of these resources, we can determine which unit tests or integration tests we want to trigger based on that change. So say for instance we change a header file that influences the way unit D behaves here, and that header file is also included by unit E and I, we're automatically picking up that any changes to that particular header necessitates tests D, E, and I to be rerun there. So in the traditional world, if you're running a single test, you would run all of your unit tests in isolation of each other. If you're doing a selective test run using our impact analysis approach, you can pull out the individual unit tests and integration tests that you require to be rerun based on that change. But also you still retain the ability to run a full regression test across your entire system if you so desire. The benefit of switching to more of a selective test run means that you can run tests more frequently. So maybe it's normal for you to run an overnight build of your regression test suite that traditionally would run the entire set. If that becomes unwieldy because the project is growing, the build time is increasing, by switching to a selective test run, you're not losing any of the benefits of that overnight build, but you're getting results back to your developers more quickly. And indeed, for some customers, we've seen that this speed up is so considerable that they can switch to selectively rerunning regression tests on every code check-in. Okay, so I'll put up a few slides showing how this integrates into the Cantata framework. We'll see this a little bit more in the demo. What Cantata does is automates the process of building your testing framework and also your test scripts and test cases. The impact analysis functionality can be initiated straight from the developer desktop. So if you're making changes to your codes and tests in a desktop project, you can speed up the build locally just by telling the Cantata IDE to identify impacted tests and build and rerun those impacted tests directly on your desktop. The same functionality is also available in command line mode, which lends itself really well to CI/CD systems running on separate build servers for overnight and kind of triggered test runs. Behind the scenes, what we're doing is monitoring the build, looking at all the source files, header files, settings files, build system make files that take place, and assigning a checksum to each of those resources. So this checksum is kind of like a fingerprint for that particular resource, and is stored as a unique string of characters. We use the MD5 hash to bring that out. By tracking these checksums for each test resource, we can immediately detect any changes to those resources and use that information to figure out which tests are impacted and which ones would need to be rerun. So I mentioned earlier, this approach we consider a test-centric approach, and it really helps drive the embedded software quality. And that means accelerating compliance with the relevant industry standards. Our Cantata tool is at the fore of that, which covers the unit testing, code coverage, and requirements linkage. We also have two other tools. We have a dashboarding, centralized web-based dashboarding tool to allow your entire team to see the progress of your tests over time, allowing a centralized view, centralized hub of the code coverage and the test pass and fail status. We also have a static analysis offering, which we can hook into your build to find things like compliance to various static analysis rule sets. So this slide is very similar to the one Rafael showed earlier with the IAR build system. So we've got kind of two places where we can leverage the power of this technology. Down at the bottom here, we've got the various developer desktop workstations where you're building your code base and designing and implementing your unit tests. Our Cantata tool sits on the developer desktop. It's an Eclipse-based tool with some quite a deep integration to the build system that you're using, allowing you to develop and deploy tests really efficiently and really quickly. Those same tests can also be taken and inserted into a CI build server, allowing you to leverage the power of your testing effort on the developer workstation and apply that to your CI build server. So implementing this process requires a well-designed build pipeline and automation, and by selecting the correct tools, continuous integration can help increase productivity through increased test coverage, faster builds and delivery, delivering of requirements at the right time rather than at the end, reducing risk, etc. So on this diagram, we can see various team functions are identified, and there's a clear flow between the infrastructure and its users. So the fundamental ideas are shown here, are kind of independent of the tools that you may apply. Obviously, we'd quite like you to consider our own tools, both the IAR build tools and the Cantata testing tools, but the methodology is the important approach. It's the methodology that can really speed things up and kind of improve the rate and frequency of your testing. And the important aspect is to allow testers to rerun and create tests as easily and as friction-free as possible, which will ultimately lead to shorter and more iterative development cycles. Okay, so let's have a look at that in practice. So the main functionality of this system is in this monitor temperature function. What we're doing is making a call to an external function that isn't part of this piece of software under test. This reads the temperature from an external sensor, compares that temperature against a number of system defined limits, and then makes onward calls to either maybe turn on a fan to cool down our embedded system, or if things get too hot, trigger a critical shutdown. We've also got functionality in here to capture the behavior to a log file, and we've got various conversion routines to convert between different temperature values for purposes of logging. So the first thing I'm going to do is to open up my Cantata IDE. So Cantata is based on Eclipse. It comes as a number of plugins that you can install into any Eclipse-based IDE. I'm going to start with creating a new project and point Cantata at my embedded workbench project area. Hit detect. Cantata will look at the files there. It's correctly determined that it's an IAR embedded workbench project. It's suggested that the build tools I want to use are the IAR simulator and ARM compiler, which is correct. I could override that and instead use a host-based GCC compiler, so I can run my tests on a host machine. But I'm happy to proceed with the IAR build tools, obviously. So hit finish, and Cantata is going to go away, look at the files in that area, and do a test build and link to make sure that the project is in a compilable state. By doing this, it's extracting all of the compile options and include paths, any defines that are set up, so that your Cantata test project mimics your production code as closely as possible. So we've imported our source here. If I switch to our Test Explorer view, this allows us to focus our attention on the things that matter for testing. So we can see our two key source files. We currently don't have any tests against those, so this area is empty at the moment. So let's begin with constructing a test script, some test cases, and a build system for this temperature monitor.c function. And Cantata automates much of the process, so things can happen really quickly. Hit generate test script, and the first thing I'm presented with is the type of code coverage rule set that I want to apply to my tests. So I can pick up any rule set based on one of the safety critical industry standards, such as ISO 26262, DR178, etc. Or I can choose something that's more generic. So for this webinar, I'll pick up statement, decision, and MCDC coverage. On the next screen, this is my cool interface control panel, where I'm telling Cantata which external function calls I want to generate stub code for, and which system calls or internal calls I'm going to be wrapping. And wrapping is a very powerful feature of Cantata. It allows us to intercept calls around the system, insert data, and check on data at the interface points. So I can expand out and get some more information about these external calls. I can see where the call is being made from, and I can change the behavior here and maybe switch from a stub to wrapping behavior if I wanted to have a bit more manual control over what's going on. I'm happy to choose the defaults, and Cantata going away and setting up my entire test framework for me to perform a unit test against that one source file. So as a result of that, I've got my test script, which is a compilable piece of C code. It's nicely commented. I've got all of the header files that I need in order to compile and link this this test independent of the system. Any global data that's going to need to be set up is done for us. We've got a main function that's been defined to give us an entry point. This enables the resulting test binary to be kind of standalone from the complete system and run in isolation. Currently I don't have any test cases, but we can come back and populate that in a moment. Towards the bottom, I've got the various pieces of stub or mock code that are required so that this system can be manipulated and tested effectively. So I can look at this either at the code level, so Cantata doesn't hide anything away. All of the outputs and files that Cantata
generates and works with are all industry standard file formats. Everything is transparent and very easy to customize. Or I can use our user interface to manipulate and kind of control our tests. So let's add some test cases here for our monitor temperature function. I'm going to choose the auto test functionality, hit finish, and Cantata will now do an algorithmic analysis of the software that we're testing to determine all of the paths through the code to generate maximum coverage according to the rule set that we set. So it's come up with 3 test cases, and we can see the reasons why those test cases are there. It does kind of natural language generation to explain why the test cases have been generated. And we can jump back into the code level to look at the test cases that have been generated, so we can see the calls to the software under test. We can see an expected calls list, so these are the external function calls that we're expecting to be made. And down in the stub section you can see that our initial template stubs have been extended so that they pass back different test data depending on which test case they're called within. So within a matter of a few clicks, I've generated a complete test script along with a number of test cases populated with test data to drive this piece of code. Alongside the test script, I've also got a complete build system that's being generated. So in the Cantata directory, under tests, here's our test script. This is our test.mk, our make file, and this contains all of the calls necessary to compile, link, and execute our test, either within this IDE system or indeed on the command line or any kind of continuous integration or build system that you have set up. So this is a completely portable system that we're building alongside your code. So let's jump back in, and we can now try and run that test. Let's do a build here, and we can see down in the console output calls to the ARM compiler, compiling both our software under test, the test script, and linking into a binary file that we can then execute in the CSpy debugger. So CSpy gets launched behind the scenes, the results of the tests are captured, passed back to Cantata, and then we get various results information coming straight to the screen. So we can immediately see some color coding on passes and fails. All of our tests are passing. We can see the coverage that we're achieving, so 42% statement coverage across that source file. But the function that we're testing, this one, monitor temperature, we're at 85% statement coverage. I can click in for a bit more detail and have a look at the coverage viewer, which gives me a color-coded view as to how my test's behaving. So a lot of this is green, which is good. Bits in yellow we've partially executed. So let's have a look at that if statement there. I can see we've exercised that twice down the false branch, but never down the true branch. So we've got a piece of kind of code that hasn't been reached in our testing there. So we can come back and address that later. As far as other results files go, we've got an ASCII format results log that gives us full detail of what we were looking for, which bits of data have been passed as expected. And we've got the same in HTML view that can be expanded out. So this is quite nice for building up a historical record of our testing. Okay, so we're trying to build up a kind of a full test suite, so we need more than just one test script really. So let's do the same kind of thing on some of these other files here. Let's go for the conversions one, generate test script. Again, choose the same coverage rule set that we had before. Let's add a test case let's choose both of those at the same time. Finish. So Cantata's given me a test case placeholder, and using the user interface I can pass in some known values. So let's feed in a value of 0 degrees Celsius and expect a return of 33 degrees Fahrenheit. And I guess we can go the other way on the other test. So we can see our 0 and 33 there on our first test. Let's put in 33 degrees Fahrenheit, 0 degrees Celsius on the other, and I can again jump back into the code, and I can see that immediately populated at the code level. That's 2 tests. Let's do a third one across both source files, so more of a integration style test, I guess. So I guess we can call it integration test. And again, give it the same coverage rule set. We've got more external calls obviously because we're going across more source files, but I'm happy that Cantata can handle that and deal with it automatically. And let's give that test some test cases. Let's keep things going quickly, so let's auto test the right temperature log as part of this integration test. So there we go, we've got two tests here. Now you saw me execute the first one that I built up inside the IDE. We can also call all of this test build framework from the command line, so let's drop to the command line quickly and change into my test area. So I think I'm there. Let's run make clean to clear away our previous test run, and now let's tell it to make all our tests, and I'll also get it to execute on the fly. So now it's recompiling every single test that we've got. So we've got 3 test scripts calling a number of different bits of test data against the software under test. We can see it making multiple calls into the IAR kind of build commands there. And if I catch the right window, we can see calls to the CSpy simulator to execute any build binaries that we're generating. So that's all happening automatically, and it would run in exactly the same way as this if you were calling it from Jenkins or some other CI build system. So the entire test framework is kind of portable there. I can jump back to the Cantata IDE and start exploring the test results in a little more detail. So we've got our temperature monitor tests that we were looking at initially, and everything that's all passing there, and we're getting some coverage. For the temperature conversions one, let's have a look. Okay, so our test is failing there, and I can see that I was expecting a result back of 33 and my actual result is 32. So I've made a mistake there in my test data, and we've picked that up. I can go back and correct that in a minute, but we'll have a look at what else is going on. Our integration test, again we've got test passes there. So let's look at the overall results we're getting. So let's open up the summary results. We can see our 3 test scripts. We can see overall coverage that we're getting across our test run there. So we've built up quite a lot in a very short amount of time, and behind the scenes Cantata is keeping track of exactly which resources we're using for each test and the last time each test was generated. So if we jump behind the scenes a little bit and look at where that data is being stored, let's go into the file system, allow us to view some hidden files, and have a look at this depends.xml. So this is the kind of magic file that stores the fingerprint or the checksum for each test resource that's required for the individual test runs that we're doing. So we've got a checksum against the overall test makefile, one against the software under test, so temperature monitor.c for this particular test. Also we've got some system header files, some project header files, the options used to build the test, and also the test results file. The CTR file is our test results log. We're generating a checksum against that, and that allows us to tie the results that are coming out of this particular test run with the precise version and state of all our resources that we use to build that test. So this is quite useful for certification. You can prove to your certification body that a particular test log file was indeed generated by the current state or the particular state of the software under test at that time. And it's by storing this checksum information that we can start to speed up subsequent test runs. So if I go back to my Test Explorer view and click in the code change verification box, identify, it's going to tell me that there's no changes detected to the state of all my test resources since the tests were last run. Now I can do that with inside the IDE, or I can open up a command prompt and run something equivalent on the command line, CPBCA, so Cantata Code Change Analysis. Identify means it will pick up any tests that need to be rerun and print them out to screen, and I'm giving the path containing my directory full of tests. And again, it's telling me there's no changes detected, so nothing needs to be rerun to keep my results file up to date. So let's make some changes now. So we had some tests that were going wrong. I think temperature conversions. So we had some wrong test data here. Expected 33 and we're actually getting a 32. So I can click into the test script and I can ask Cantata to suggest a fix. It's telling me to change the parameter there to 32 to fix that check failed, which I can do just by double clicking. Or I could fix it directly into the IDE. So this one here, Fahrenheit to Celsius. I was expecting a 0 back, I'm actually getting a 1 back, so let's correct that there in the user interface. So I've made now a change to the test data that I'm passing in for the test, and I can see what Cantata makes of that. Hit identify again, and you can see here it's telling me that the temperature conversions test is impacted by changes to its dependency because we've changed the test data, and the suggestion is that we should rerun that. So again, I can do the same thing on the command line or in my CI system. So let's quickly rerun the same command again, exactly the same, identify, give it the path, and it's telling me that temperature conversions is impacted by changes to the dependencies, which is correct. I could dive in a little bit deeper, so if I pass in another option here and ask it to log out a bit more information to the console window, I can then really see what's going on behind the hood. So we can see it reading the make files behind our test, picking out all of the dependencies for all of the tests in our project, generating checksums against all of those test resources, and then doing a comparison between the current state of that resource and the state of the resource at the point the test was last run. And I can see here that we've got a difference that's been detected on test temperature conversions.c, so the checksum has altered, that resource has changed, and because of that it's suggesting that we ought to rerun this temperature conversions test. So I can do that quite quickly if I, instead of calling identify, call the build option. Cantata will do the full analysis, and immediately after doing the analysis it will rebuild and rerun any tests that need to be looked at again based on changes to the results files. So new test data, and that's just one command that we've issued. So if we're running in our CI system on Jenkins, we just get Jenkins to call that command, that cppcca mode build, give it the directory full of tests, and it will go away and do the analysis and just selectively rerun tests that need to be rebuilt based on any changes since the last run. I can pick up changes in other ways, so let's go back to my embedded workbench, and I think we had some dead code on this monitor temperature function. So if I refactor this code a little bit, swap around some of these else if statements, and make a change there, go back to my console output and get it to identify any changes. Let's put the full log back on. We can see here we've got a difference in checksum on temperature monitor.c, the file I've just edited, and because of that it's suggesting we ought to rerun both the integration test that includes that file and also the unit test on temperature monitor. So again, just by calling the build, let's get rid of some of that logging, we can immediately recompile that and generate some new results. So that's basically it. It's a very useful facility, keeping track of all of our test resources across our project. For larger projects, obviously, the complexities of dependencies can increase quite significantly, and also if you're trying to rerun all of your tests on a regular basis, you're going to slow things down. But by using this impact analysis and selectively identifying exactly which tests need to be rerun based on changes, you can get some significant time saving there.
Great, thank you, Adam, for the excellent demo. So let's summarize this. So as you saw, development projects need to be continually monitored with complete precision and rigor, employing the latest tools and techniques to achieve measurable success. So the development tools from IAR Systems and testing tools from QA Systems enables companies to benefit for a lower maintenance cost, accelerated release schedules, and reduced opportunity for a flaw to go unnoticed. So now it's time to go over the Q&A. I hope you have sent your questions in already, and we will spend a few extra minutes to make sure we can answer your remaining questions. But if anything else pops up, you're always welcome to reach out to fai@iar.com. That's from IAR Systems side, and also info@qasystems.com. Any questions related to Cantata and QA Systems.
That's great. Thanks, Rafael. I'm joined by Rob, who leads our US support team to help delve into the questions that are coming in. Which one should we tackle first, Rafael?
Good, yeah. I can see that we already got a few good questions in here. I can see maybe the first one here, if we start by the licensing question here. What are the licensing options that are available for impact regression tools? So that's definitely for you, Adam and Rob.
Sure. Rob, do you want to take that?
Yeah, sure. So our licensing model with Cantata, the tool that Adam demoed here for our regression testing, is actually fairly flexible. So you can do load lock licenses to your local test machine, or you can use floating licenses. We support in the floating license concept the idea of subscription licenses, as well as permanent licenses with annual maintenance renewal. And we support different pricing options for geo-binding, meaning for local LAN up to worldwide licensing. So whatever level of licensing and whatever pricing is the most convenient for your company, we can probably find a solution that works for you.
And I think for CI systems, floating licenses are quite a good option. It allows you to use the same license pool during the day for your testing activities, and then if you're rerunning tests overnight in your CI pipeline, that can hop on and grab the floating licenses at that point.
Good, and I can continue here. That is actually a bit similar with license, but it's more connected to the trial. So that's on IAR side. Is there a trial for the IAR ARM command line tools? I can only find IAR Workbench at your website. Yeah, so the IAR build tools for ARM, they are actually not available for evaluation from IAR.com. So please, what I can suggest is reach out to fai@iar.com, so we can connect you to the local representative or contact to check the possibilities for the evaluation. Yeah. Let's move on because we don't have so much time for the Q&A. So there is another question here for QA Systems, Adam and Rob. How effective is auto test at generating suitable test cases? That's Cantata, yeah.
So what Cantata does when we run autotest is that it parses the dependencies of your entire application, and from that deciphers what it would take to achieve a certain level of code coverage. So if your code is very straightforward and easy to understand, then you could reach 100% coverage and basically be done just by hitting autotest. In more realistic, complex scenarios, I frequently see just by running autotest that you basically achieve 70 or 80% coverage out of the box, and can then use that as a very healthy baseline to finalize and develop your test to achieve really covering testing all the functions and all the modules that you want to test.
Good. And there is another question here related to the safety version. That's for IAR systems. what components in IAR Workbench are pre-certified? That's a question that comes up often, and it's a good one. So actually, the compiler, linker, assembler, libraries, so mainly the full build tool chain and all its features. When I say features, like optimizations, extensions, are actually certified in the IAR embedded Workbench. Yeah? And the same, of course, is also valid for IAR build tools in this certified edition. Yeah? Good. I can see that the other questions have been answered also here on the question panel. So we will stay connected for a few extra minutes. Make sure to send in your remaining questions. Otherwise, as mentioned before, you can see the contact emails that you can use. Otherwise, I would like to thank you for your attention today and hope to see you soon in the next webinar. Yeah.
Thanks for joining, everyone, and hope to see you again soon.